While reading CSV data and manipulating it with Pandas is interesting, it would be even more interesting to integrate SQLAlchemy so we can access data from a live database. In our virtual environment, let's install a module that lets us connect to a database from our application. We'll be connecting to a SQLite database, but you could connect to a different type of database as well. Let's install SQLAlchemy. Let's start up Juypter Notebook. Our database is stored in a file called Salespeople SQLite, and it's located in the exercise file, specifically in our Pandas workspace. This database has a single table called Salespeople that lists different sales representatives working for the company. Let's use SQLAlchemy to connect to this database. We'll use Create Engine to connect to the database, Salespeople SQLite. While this is fine and dandy, we might want to make our application a little more dynamic. Instead of hard-coding the database name, we could make it an environment variable for our computer to read into the file. All we have to do is stop our notebook and export the value we want it to be named. We'll export salespeople DB URI and put in our connection string. Let's restart the notebook. If you happen to get an error in the right-hand corner, just refresh the page. We can access our environment variable using the OS module's environ. From OS, we'll import this tool. Then we'll use it to retrieve our environment variable. We'll pass that in to our Create Engine function. If you happen to get an error, you can always rerun your cells to make sure everything is imported. And there it goes. Our database is now connected to our application. In order to use data in our application, we'll need to import it. In fact, we can load the data directly into a Pandas data frame, making it really easy to work with. We can use the readSQLTable method to load a table from the database. The table is called Salespeople, and we'll pass in our engine's connection. While adding just these two arguments will work, we can actually be more specific in importing our data. Extra parameters make sure the data is read in as expected. Let's walk through these parameters. The index column allows you to pass your primary key or another column you want to use as an index to your Pandas data frame. Coerce float looks at the columns containing numerical values and tries to convert these columns to use floating point numbers, where valid. It's automatically set to true by default. Columns allows us to create a data frame with specific columns from our database, excluding the others. It's similar to the SQL select on X columns statement. If we have date column types in our database, we need to explicitly state them so they're converted correctly when creating our Pandas data frame. Chunk size allows us to create a generator object where data is streamed a certain number of rows at a time, here 250, rather than all at once. In analyzing the data, you use the generator to iterate over chunks of the data. For now, we'll comment this out so we have it for reference. It's important to note that SQLAlchemy 2 is very new, and with all new things, they're likely to change. If this statement doesn't work for you, consider looking at the linked documentation. Let's take a look at this data frame. Here's our data in a Juypter notebook. Let's grab the email address data. We'll access our data frame, salespeople df, and retrieve the email address column. Lots of emails. These will likely be different for each entry. Let's check out another column. Say the state. There are only 50 states, so some of these are likely duplicated. Let's create a quick visualization to see which states most of the salespeople are from. We'll access that same column and use value counts. It looks like most people are from Texas. Let's see it with a bar graph. For this, we'll import Matplotlib. It'll be a bar graph. A few from Minnesota, Florida, and Virginia, too. It's pretty incredible what you can do with Python when you combine several libraries and tools with databases. It's time to practice ingesting and visualizing data. In this challenge, you'll be given a new database that you need to visualize the data of. Here's what the data looks like. There are columns for order ID, property ID, state, city, product ID, product category, product type, quantity, product price, and order total. It represents sales for the land and company. We've already transferred this data into a SQLite database file called Landon SQLite. It lives in a table called sales. Your job is to import this data into a Juypter notebook. Then, you'll create a graph that visualizes a statistic or fact of the data. It could be a bar graph that shows what city most orders came from. It could be a pie chart that shows the least popular product categories. It's up to you. Good luck and happy coding. Let's practice ingesting data from a database in Juypter Notebook. We'll start by importing SQLAlchemy. SQLAlchemy will help us connect to the database. To connect to the SQLite database, we'll create an ingest. The input will be our SQLite file with our data in it. That's SQLite, Landon, SQLite. We'll ingest the data with Pandas. And we need as PD, so we can reference it as PD in our file. To read in the table, we'll use the read SQL table function and pass in our table name along with a few other inputs. These include the connection and the index column. Order ID will act as our primary key, so that's why we set it in our index column. Let's visualize the data. We can sort the order totals and view them with the sort values function. We'll use that on the data frame. We'll sort the values by order total. It looks like one of the smallest orders was $3, and the largest were $900. We can also see where the order came from. Let's check out how many orders came from each state. We'll use the property state column and the value counts function. Most of the orders came from Virginia and California. We can view this as a pie chart with Matplotlib. We'll use the pie function to create a pie chart of the top 10 states people ordered from. It'll use the value counts of the property state column and then the associated column values to create the chart. To retrieve the first 10 rows, we'll use .head. Now, we'll want to label each piece of the pie using the column value. So that's California, Virginia, Pennsylvania, or whatever the state is. To retrieve this, we'll take the code we just used and then access the index. Then we'll convert that to a list. That'll give us the state labels we want in list form. Let's run it. One thing we forgot here is we need to add labels to the beginning of this. This sets the labels for our data in the pie chart. Here it is. It looks like we're only seeing 5, and that's the default if you don't put an argument in for head. We want 10 in there, so we'll put 10 as the argument. And there it is. We have 10 states in the pie chart. It looks like Virginia and California are pretty similar, and Washington is about half of California. If we look at the numerical data, Washington is close to 250, and California is close to 500. So this pie chart looks accurate. Congratulations! You just analyzed and visualized data from a database using Python.